Welcome to the playlist on statistics. Let me write that down. And statistics really is just all about understanding data. Understanding data. And I'm really excited about this because this is a really interesting area of mathematics. And this is something that we all could and should use in our daily lives, unlike some other areas of mathematics. And because even if you don't get into a job where you're directly involved with data, we all see data in our day-to-day lives. We see them in scrolling through our Instagram feeds. We see them on billboards. We see them in television ads. And if we don't know how to properly understand or comprehend that data, we might be misled, because there could be arguments that might seem very confusing, backed by data, by proof. And it might seem to you that it's right, but it will actually be quite wrong. So it's really important, as Mark Twain said, that there are lies, then there are damn lies, and then there are statistics. And he was quite true, because if we don't know how to understand data, it's going to be really hard to survive and to live in this modern age, in modern and digital age. So let's just get right into the meat of statistics. And statistics can be broadly classified into two areas. The first of which is descriptive statistics, in which we learn how to describe data. And once we get good at that, we go on to inferential statistics, where we make inferences from data. We make conclusions. We reach conclusions from data. We analyze the trends and we predict the future. And so in this video, we're going to be talking about the first part. So to make you understand that, let me give you an actual example. So let's say you have a garden and you have plants in your garden, and you measured the heights of your plants. So one came out to be 5 inches tall, and then there was another one that was 6 inches tall, and then there was one that was 4 inches, and then one that was 3 inches tall, and then maybe one was 2 inches tall, and I don't know, maybe one was 4 inches tall. And so somebody comes up to you and asks you, how tall are your plants? And now you don't want to say that, oh, one is 5, one is 6, because that could be time consuming and quite boring, frankly. And what happened if you had 20 plants? So that would take up a lot of your time. So the goal here is to come up with a way to describe this data in a way that you don't have to say all of these numbers. And one of the ways to do that is the mean, is to find the mean or the average of the data. And it's a very simple idea. All you do is you simply add the digits. So you take the sum of the digits and then you divide it by the number of digits that you have. So in this case, it would be a 5 plus a 6 plus 4 plus 3 plus 2 plus 4. And all of that divided by how many digits are there. So there are 1, 2, 3, 4, 5, 6 digits. So that's going to be your mean. So let's calculate it quickly. So 5 plus a 6 is an 11. 11 plus a 4 is a 15. And then plus a 3 is an 18. Plus a 2 is a 20. And plus a 4 would be 24. So 24 divided by 6 is going to be 4. And so you would say that on average, the height of your plants is 4 units, or 4 inches. So another way would be to find the mode of your data set or your numbers. And a mode is simply the value that occurs the most. So the most occurring value, I could write that down. So which value here occurs the most number of times? So that would be 4, because you have 2 plants that are with the height of 4, and so the mode would be 4. And you might be wondering what happens if none of the values get repeated. So in that case, you would have no mode. And what happens if 2 values have the same number, occur the same number of times, and both are the highest number of times? For instance, In this case, you could have had, instead of this 3, you could have had another 2. So in that case, both the 4 and the 2 would be the mode. And the third way to describe a data set would be the median. And the median is essentially the middle value in a data set. In any given data, the middle value is your median. So how do we get to the middle value? So first of all, it's obvious that we need to arrange our data in order, and so we need to arrange them in increasing order. So the smallest number here is a 2, and then we have a 3, and then we have a 4, and then another 4, and we have then a 5 and a 6. So in this case, it turns out that we have an even number of numbers, right? We have 6 numbers. So if we had, let's say, 5 numbers, let's say the 6 wasn't there, so if I just cross it out for a moment, then it would have been quite simple, because you have 2 digits here, 2 digits here, so we have a single middle digit, that would be a 4. So that would be your median. But in this case, we have 6 numbers, so we don't have a single value for the median, or at least we don't have a single number that's in the center. So to find the median in those cases, what we need to do is we need to take the average of the 2 middle numbers, right? So what are the 2 middle numbers going to be? Well, a shortcut to finding that out is something I always remember is the n plus 1 over 2th number, right? So that's a shortcut to getting to the number that you need to find the mean. So if you had, let's say, if you had 99 terms, then the median would be the 99 plus 1 over 2th term, which would be 100 over 2, which would be the 50th term. So that would be your median. So that's just a shortcut to remembering which term would be the middle term. And in this case, since we have 6 terms, it would be the 6 plus 1 over 2th term, which would be the 7 over 2th term, or the 3.5th term, and there's no such thing as the 3.5th term. So this would basically just be the average of the 3rd and the 4th term. So the average of the 3rd and 4th term. And the 3rd term here is a 4, and the 4th term is also a 4. So that's a bit lucky. So this is going to be a 4 plus 4 divided by a 2, because the number of digits here is 2. So that's going to be 8 over 2, which is also a 4. So that's your median. So this is about it for this video, and I hope to see you in the next one.